In this part of the video, we are going to look at graphing the derivatives. So let's review some calculus at this point. What does the first derivative say about the function? Remember how that was? When the first derivative is positive, the function is increasing. When the first derivative is negative, the function is decreasing. And we have a critical number when the derivative is 0 or it does not exist. Like here, it's 0 and it's 0. And you find your critical points. Now, if we are doing a first derivative test, if a function is increasing first and then decreasing, that means you are going to have a local max. If it is decreasing first and then increasing, you are going to have a local min. Now, if the f prime does not change sign, but it stays all positive, and that may be on both sides of the critical point, then you'll have an inflection point right here. And the same thing. So it is not a maximum or a minimum at that point. It's neither. Now, when we go to second derivatives, you are going to have a concave upward situation when your second derivative is positive, concave downward situation when your second derivative is negative. You can do all this by hand. And what happens when the f double prime is 0? You will have an inflection point. Alright? And then the concavity changes at that point from up to down or down to up. Now let's look at a function f of x, x to the fourth minus 4x cubed. We are going to go and enter that, and I entered that. You can actually use calculus and take the first and second derivative by hand. And I did that. If you look in here, I just entered those things in here. Alright, now let's go to the next slide. Now, I can look at the sign of f prime by factoring. Now, I know that this x squared is always positive, so this doesn't come in the picture of changing sign. But look what happens at 3. When f prime does change sign at 3. Now, it's going to be negative before 3 and positive after 3. Okay, so it is an increasing, decreasing kind of situation, or decreasing, increasing kind of situation. And remember how you used to do that, using the number line and checking the sign of f prime. F double prime, you do the same thing. Now you have two things that are going to affect the f double prime. It is 0 and 2. And you know that there is an inflection point at both places, because that's when the f double prime is going to be 0. So you can do all these analyses yourself, and you can look at what's going on at where you have critical points, and you can find the concavities and all that stuff. So what you need to do, you can then make a little table and find out where things are increasing and decreasing for both the first and second derivative, and find the concavity using the second derivative, and you can draw your function accordingly. Now, it is a good idea, if you have your graphic calculator, just to double check, and I'll show you how to enter those things. And if you did this by hand, and you're not sure if you took your first and second derivative right, what you can do, you can enter the formulas in here, and then look at the graph. I set my window equivalent to what I did before, -5 to 10, and so forth. And when you push graph, you're going to see, let me take the second derivative out of the picture and make that disappear. Here it is, the function and the first derivative. Okay, I can make the first derivative a little thicker. Let's do that. I'm going to go to the left and push enter, and it makes it thicker. You can see it here, and graph. So we actually duplicated what we did before. Now, but I'm not sure, let's see, this does not look the same. Okay, so let me go and see. Maybe I did enter that one wrong. It says 4x squared times x minus 2. Let me put, it doesn't look the same. So I will put the 4x squared, the insert left parentheses, and then the right parentheses. All right. Okay, now let's look at the graph. Oh, this is what I did. I was just, my eyes were, I did the function thicker in there, and the first derivative thinner. That's what I did, so I could not see. Let's go and do that. By just pushing enter, I am here we go. Oh, I put dots. One more try. I'm going to change those dots to just a solid line, but not as thick. Here we go. I think that is the right one. Okay. Here we go. So the function and its first derivative. Okay, here we go. Now, I'm not sure if I took the first derivative right. So what you can do, you can go in here and enter the first derivative using the end derivative button. Remember that was in the math menu. I will go to the math menu, scroll down, and we'll take that end derivative thing. Okay? The derivative of what? y1. Remember where we used to take that? y1 is in this y variable area, function. Take that one. And then you're going to go, comma. It is a function of x, comma, x again. Now, I will take the first one out. So if I did the first derivative right, here we go. The y2 and this y4 have to be on top of each other if I did it right. So that's a good way of checking. So let's push graph. So this one is what I did by hand. And the second one is on top of it. That means I'm not going to see any difference. It's still thinking. You see, it's still thinking in there. And it's done thinking. They are on top of each other. So I did it right. You can focus in and just make sure that you got it. They are exactly right. You can do the same kind of check with the second derivative. Remember how I did the second derivative? I just did it by hand and put it in y3. And I can do the same thing. Now this time what I can do, make that one inactive and go to y5. And I will now graph the second derivatives, y3 and y5, on the same graph. How do I take the second derivative? By taking the derivative of y2. And I can do that. So let's do that. I go to math menu again. So I'm actually playing right now. And there are so many features that I can use. Here's end derivative. Now I'm going to take the derivative of y2. Where do I get y2? From the variable. Here we go, function. Here is this time y2. I'm taking derivative of the derivative, comma, x, comma, x. Very good. So if I took the second derivative right, y3 and y5 should be on the same graph. It does not like it. So let's try it. Let's see. I will put here, I will put 4x squared times x minus 3. That is correct. I have two commas in here. That is what the calculator did not like. Alright, so let's do that. Y2 comma x comma x again. And that's what it was struggling with. Alright, now let's push graph. Okay, second derivative. It's still thinking, but at least it did not give me an error. And it's almost done. And when it's done, okay, here's it's done. It looks like we got it right. So, you can pretty much play with doing it by hand and use the end derivative button to double check your derivatives, to see your second derivatives, to check concavity, and there are many ways of checking your work that you did by hand.